and gentlemen, it is Trisha here today, July 7th, so I hope you all had a wonderful 4th of July. If you're here in the United States, that is our Independence Day. We shoot off fireworks and go on picnics and spend time with family on the 4th of July. I hope that you all had a wonderful one. I have a kind of funny story to start off. I was watching the fireworks, but my boyfriend and I decided to go all the way across the river into New Jersey so that we could watch the fireworks in the Philly region from over the water, so that we were a little further away from the people. We got to hang out on the beach and do a picnic, and it was wonderful. And then when we were heading on the way out, we realized that the park actually had locking gates and we were locked in. So I got to see something like 6 different species of fireflies while we were waiting for our Uber home, and I was really excited about that. I was watching all of their different flash patterns. And if I had any vials with me, I probably would have collected a couple. But, you know, so we got locked in, but we got to see a bunch of cool bugs. So, you know, win-lose. We had a wonderful time. Yeah, exactly. And so, today I've been doing this thing. I have 13 specimens of click beetles. I have 13 different individuals, and I believe that they are all different species. There might be 1 or 2 that are similar, but I've been trying to identify them. And click beetles, identifying them to species is a little bit more difficult than you might expect. And so we're going to be talking about them today because I spent the first, 4 or 5 hours of my day looking into keys and trying to identify as many as I could. I was able to get this one identified all the way to species with the help of a friend on iNaturalist. I say friend loosely. With the help of an identifier on iNaturalist, I was able to get this one all the way down to species. So I figured this was the one that we could do. It's actually a fairly large specimen, so this is all the way zoomed out. And I'm going to go ahead and just scooch our specimen up so that you can see the length of its body. So it's pretty long and narrow. It's got super long elytra. Welcome, Jody. And it has this really, really beautiful, fine hair all over it. So let's go ahead and zoom in really quick. And for those of you who really love textures, I absolutely love the texture of the exoskeleton and of the hair in this beetle. Alright, so I'm going to go ahead and turn. You can hear the click! Yes, exactly. This one, I mean, we're going to go ahead and put a ruler next to it so that we can go ahead and measure it for those of us who like to have measurements for our nature journals. So from the front of the head to the end of the abdomen, we're looking at maybe like 33 or 34 millimeters, so 3.3 or 3.4 centimeters. I'll go ahead and put that in the chat just in case we have any latecomers and want to come and visit. So that's going to be the length of this absolutely stunning beetle. I collected it last summer just north of St. Louis at a state park called Quiver River State Park. All right. Now, I I think what we're going to end up doing is drawing, or at least looking at, both the dorsal and the ventral views on this click beetle. We really, really do need to flip it upside down to see all of those mechanisms and awesome things underneath that make it and help it click. Because as you know, this is a click beetle. I don't know if I've given this to you yet. So all click beetles are in the family Elateridae. Alright. This one, I believe it is in the subfamily Elateridae. But we have this as the species. We call it Orthostethus infuscatus. And I've been learning some new fun words today that revolve around click beetles. And so we're going to go ahead and learn them together, or I'll share them with you. So I'm going to go ahead and start my sketch by just writing this name up here on the top. It does not have a common name for the species. A lot of click beetles... Damn it, I don't think I can write Latin and talk at the same time. Alright, so Orthostethus infuscatus is going to be our species name. And a lot of individuals like click beetles, they don't have a common name for the species. They have a common name for the entire family. There are a handful that are named. This one in particular, you may have seen this in your region. They're fairly common across the United States. Or at least the eastern United States. We call that one the eastern-eyed click beetle. That one's also pretty cool and easily identified. But I love this one for the pattern, so I figured we would sketch this one today. All right. I really wanted to be able to see both the head and the pronotum. There we go. As much as we can see. And if you have any questions about click beetles, you can always go ahead and shoot them in the chat. I'm going to go ahead and I'm not going to center my sketch because I'm hoping to do both a dorsal and a ventral. So I'm going to go ahead and kind of imagine my specimen on just one half of my paper so that I have enough room to do both. We'll see if that works. As a lot of you know, I like to go ahead and make a very light overall sketch with very little features, mostly just basic shapes to make sure that my specimen's going to be about the right size and I'm leaving enough space on the paper. So I've got a very, very small kind of flat oval head up here at the top. There's not much depth to it if you're looking at it dorsally, but when we look at it head on, you're going to see all different types of characteristics on the head, including this frontal ridge that's in a lot of keys. I've been looking at it a little bit. Alright, so our pronotum is this whole big shield, and it's going to have... All click beetles are going to have, on the edge of their pronotums, they're going to have these spines on the edge. That's going to be essentially your first characteristic. If you're looking at a click beetle from the top, your first thing that you're going to see is these edges on the pronotum. Alright, so that's going to be kind of the first thing that you notice if you are going ahead and trying to find click beetles, or you see a click beetle. Alright. The other thing, so we've got our head, our pronotum. It looks like we've got a handful of new people here. Welcome. Feel free to chat with me or ask me any questions you'd like. I do like to go ahead. I wrote pronotum up there. And that's this whole section right here. All right. I'm gonna be scooching our specimen up a little bit so I can get the overall shape of our scutellum and the elytra. Alright, so if we're looking right about here, we do want to kind of imagine ourselves a middle line down the insect. As we know, insects are symmetrical, so you want to make sure you're the same on either side. But also that helps us for beetles as to where their wings meet in the center. They're always going to meet centered. Alright, I have this little friend. We never ended up naming him. So, he doesn't have a name just yet, but, he carries this little arrow and helps me point things out sometimes. This little kind of knob-looking shape right here in between the elytra, that little piece is what we call the scutellum. And it is one of the characteristics that you have to look at if you're identifying a click beetle down to species. Sometimes click beetles will have a heart-shaped scutellum, and it is so adorable. Alright, would you be able to zoom out while we draw the basic sketch? This is, I believe... Alright, so this is as far zoomed out as I can get, but the other thing that I can do... Didn't we name him Dippy the Diptera? Alright, we can name him Mr. Dippy. I thought we were joking. What I can do is keep this specimen over here so that you can see the overall body shape. He's a little dark here, but that image is as zoomed out as I can get it. Oh, yay! Thank you, Aisha. Alright, so right here in the very, very center, I'm going to go ahead and give myself essentially what this is, just a little scutellum. It hangs out in between the another word of the day, the elytra. Well, we've heard that one a couple of times. The elytra are these wing shells, the first pair of wings of a beetle. That very, very super hard shell. They don't really help for flying as much, but they do help with protecting their membranous wings. So the edges of our beetle are very even with this prenodal spine. So I'm going to come down like this. Alright, so you're going to try and make it come down evenly and centered so that they meet generally rounded at the end. And we'll go ahead and we'll scooch the microscope image a little up so you can view the end of the elytra. If you guys like Mr. Dippy, I just thought it sounded kind of like, I don't know. I guess it sounded kind of silly, but we're allowed to be a little silly in class. It's allowed. Alright, so that's going to be my very, very light outline of... This is going to be my very, very light outline of my beetle. I'm probably only going to worry about... Well, let's just see. Maybe I will do the legs on the right-hand side. We'll see about that. Awesome. Terry is a cute name. That's a lot more. It's very it's humanoid, which is kind of fun. Oh, Aisha saw a click beetle that glowed. Those are super, super duper cool. I actually collected glowing click beetles in in Texas one year, and I thought that they were just the coolest thing. Because we were seeing them light up in the distance, and I didn't think, the first thing you think of is firefly, right? You don't think click beetle. And so, when I turned on my black light and all of the beetles started coming into the light, there weren't any more fireflies in the yard. And I was like, wait a minute, what happened to all of the awesome insects that were glowing out in the field? Where did those go? And I discovered that they were the click beetles that were flying into my light. And I couldn't see them glowing as much because the light was on. So I would turn the black light off just to watch the beetles glow. Alright, so this is the image of our head. I know we're seeing it from another angle, but I wanted to share it with you. Alright, so we're looking at up at the top of our head, right about here, and here are our compound eyes. Alright, the antennae are actually tucked kind of up and underneath, so when we flip over the beetle, we'll be able to see the antenna a little bit better. Right down here, you can see it's a little out of focus. Maybe I'll zoom down the focus so you can see it a little clearer. That guy right there is one of those labial palps, so it is a mouth finger. It helps push food towards his mouth. And then you've got some mouth parts, some mandibles down here. You also have a little bit of a labrum, but, yep. So, let's see. I was trying to think that there is a name for, I believe that there's a name for this ridge that goes across the head from the eye to the other eye right here. So you can see it's kind of hardened and it's kind of shelf-like above the mouth parts. And there's a word for it. I remember it being kind of, I think it has to do, it's like a frons. I will find it before the end of class. You'll just have to remind me. The frontal carina. Supraantennal carina. So, it's essentially this hardened part of the exoskeleton that kind of creates a shelf right here. And the fact that it is a shelf, it's like another level from the mouth parts, is a character that you need to know to get it down to species. Alright, so, I know I love looking at him from the head, but it doesn't help me much when I'm trying to draw him dorsally. So I'm going to go ahead and scooch it back to where it would be kind of what we're looking at here. So you can see the eyes on either side and these long, these short hairs. I wouldn't say they're too long, actually. They're short. There's just many of them. Many of them. Okay. So, as you know, a lot of times I will just go in and kind of erase my basic shapes as I'm going through and editing. Let's see. So, I'm going to start with kind of backwards parentheses here and here. That's going to be the inside of my compound eyes. And I'm just going to go ahead and make these compound eyes kind of separate. And then you've got this frontal ridge. I think that's what we're going to call it. We're going to call it a frontal ridge. And that's up here, and it kind of covers up some of the mouth parts up there. We are going to go and add the antenna probably right about in this area. But we'll do that after we get the body taken care of. All right, so we've got the head kind of taken care of. We do have a lot of texturing on. We do have a lot of texturing on the exoskeleton, and if we were talking about how entomologists would describe this texture in a key, we call this texture finely pubescent. I've always thought that the pronotal shapes of click beetles, of elaterids, kind of reminds me of a bell. Alright, I'm going to come back into this, and I'm going to go ahead and start solidifying some of these pronotum lines. Just making sure that we keep this very kind of bell-shaped, and it does look like it comes in just a little bit before it goes back out. So, right about like this. So I was also making some like internal jokes in my head while I was reading this because the scientist who wrote this key also came up with his own names, with his own words for colors too, or at least words that I had never heard of before. So he would describe this click beetle as castaneous. Does anyone know what color that is? Bonus question. Do you know what color might be the word castaneous? So that's close. Golden is pretty close. We consider castaneous. Ivea's got it. Chestnut colored. All right. And so when he was writing this key, it said something like, oh, I laughed. It was body castaneous to Rufo Pisceus. And I won't have you guys guess what Rufo Pisceus means. It actually took me a while to break down the words. Rufo means reddish, and Pisceus means black. So when you're talking Rufo Pisceus, you're talking about a reddish-black color. You know, I don't know why. Sometimes I laugh because, you know, I don't know why we don't just use chestnut colored. But castaneous sounds a lot more scientific, I guess. Is Castania the genus for chestnut? I'm surprised so many of you guys knew that. Look at you. I had to look it up. Alright. Our margins. Cool. Alright, so these are our elytra, right? These are our, there are 3 plant nerds in attendance. Oh, I love it. You guys probably use very similar colors, too. I was wondering because at one point he says Pisceus to black, or black to Pisceus. And I thought that Pisceus did mean black, so it might just mean a darkish gray color that's almost black. Alright, I've got the edges of my elytra. They're gonna come down. Hi, Hashi! Oh, I see your hand. Texas too. What part of Texas? I was in. I'm sorry, I missed that question a little back, Aisha. Let's see. When I found those beetles, I was in western Texas. I found them in Boy Scout Canyon, which is on Boy Scout Road near the Davis Mountains. And I don't think that was the time that I got reined into the canyon, but I definitely got reined into Boy Scout Canyon once. When it rains in Texas, it really storms. Alright, so this is going to be our overall body shape. I'm going to admit the top side of our click beetle friend here, he doesn't have a crazy number of defining characteristics, but I didn't want to just draw the bottom of our beetle without looking at the top. So this guy is kind of like this, and if I would probably, if I had hours, go in and add all of that texturing. And you can go ahead and add that if you'd like. I'm going to scooch my specimen over so we can check out some feet. I personally love that. Oop, that's a little dark. I wanted. This will be about right. So the front, middle, and hind legs of this beetle are all very similar to one another. So I'm just going to be showing us one of them. And then you can almost copy and paste. We'll flip over the beetle, so I'll show you where they should be coming out from around the body. But we know that an insect's leg goes femur, and then tibia, and then tarsi. So the sections that we're looking at here, Terry can come and help us out. This is the tibia right here. And then we've got let's see, count this way. 1, 2, 3, 4, 5 tarsal segments. And I believe elaterids, all click beetles, have a 5-5-5 tarsal pattern, meaning the front, the middle, and the hind legs, they all have 5 tarsal segments. All right. We do have very, very, very fine pubescence, or very, very fine hairs along the length of our leg. And if we zoom in really close to the tarsal segments, there we go. Sometimes I can get these to glow really well, and sometimes they stay a little bit darker. But if you look at the very bottom of the tarsal segments, they've got these very thick pads of hairs. They have like these thick hairs, pads on the bottom of all of their tarsal segments, and this is going to be something that's going to help them stick to the surroundings. It helps them hold on to whatever they're walking on so that they can walk in all directions, you know, hold on upside down and not blow away. Oh no, don't move. It's going away. Come back. Sometimes I think I'm just going to move it just a little itty bitty bit, and then you know, it's a microscope. All right, so I'm going to go ahead and leave that here so that we can see those tarsal segments. When we are actually, so our beetle doesn't have super, super long legs. He's kind of got short walking legs. We call walking legs ambulatory, because they kind of amble on them. And the first pair of legs are going to be connected right here on the pronotum. So we can go ahead and add a tibia. The femur is going to be, let's see, if our leg comes here, the femur comes out, and then the tibia is going to come up. So maybe from down here. So we've got a tibia, and then we've got these tarsal segments. Now, we do have 5. I believe I have the last 4 on the camera. And so you can see that it's got... They're kind of stacked up against one another, and the first 2 are subequal, and the second 2 are subequal. So the first 2 are a little larger, the second 2 are a little shorter, and then we've got that longer one with the 2 tarsal claws. Now, my sketch has gotten... I have to draw mine significantly smaller. My tarsal segments got really big, really fast. So I'm gonna go, I went back and I had to shrink down my tarsal segments a little bit so that they are about in line with our size. But alright, let's go check out where the middle and the hind legs would come out from our body so that you know approximate range for that. And then we're going to flip it over so you can see all of the fun characteristics. So, let's see. Scooch it out, scooch it back. Alright, so you can see the beetle's knees. It's not the bee's knees, it's the beetle's knees. Right here and here. So this is the femur coming out and the tibia scooching back in. And honestly, if you were watching one of these beetles, if you were just watching it sit, it would probably be sitting in this as a very natural pose. So if you wanted, you didn't want to go ahead and sketch all the little tarsal segments, you could just go ahead and give him some knees. So bringing out our second pair of legs right about in this region, and then pulling them back. And then our third pair of legs are actually found closer down here. And when we flip it over, you'll see that even though the leg looks like it comes out way down here, it still is connected to the thorax. All 6 legs are connected to the thorax and not the abdomen. All right. There's something wrong with this leg. I will fix it when I figure it out. Because I want to flip this buddy over. Oh, I also want to show off his antenna. Alright, he's going on his side for a minute because click beetles have serrate antenna. Serrate is a word that you plant people know. So when we're talking serrate antenna, a lot of times we're seeing one edge of the antenna, that top edge right there, is smooth, and then the bottom edge will be jagged like a knife. Alright, that's what I think of when I think of serrate. I think kind of sharp like a knife. And each saw-like. Oh, NC Doggo, I forgot we were going to do Japanese beetles today. I saw that you suggested click beetles, and we did those instead. I'm sorry, NC Doggo. I will write it down and make sure we do them on Sunday. Are you around on Sundays? Alright, so our antennae are coming out from... Okay, so if you're around on Sundays, I'll make sure and we'll go ahead and sketch that one on Sunday. Right here, underneath the ridge, in kind of in between the eyes, this is where our antenna is going to be connected. I am so happy you guys come here all the time. It makes my day. Don't drop the bug. Dropped the bug. I wanted to zoom in on the second antennal segment, which is why I was touching the microscope to begin with. In some click beetles, this second antennal segment right here is the same length as the third antennal segment. In this species, it's about half the length, and that's something that we do see in the keys. So I wanted to go ahead and make sure we saw really close up what that looks like connected to this head here. And then we have this longer segment that comes out around this way. That's our first segment. Our second one is kind of small and knob-like. All right. And then the third one is really going to be starting our serrate pattern, where each segment kind of has its own sharp point. And let's go ahead and count those segments. Hello, Suggest Me. Welcome. If you have any questions, feel free to ask. We've got a pretty good chatty group on Thursdays. We are looking at serrate antenna, and it's got 1, 2, 3, 4, 5, 6, 7. Let's see the entire antenna so that I can count the segments. I believe it's 10, but it could be 11, and so that's why I was wanting to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So our friend here has 11 antennal segments. All right, 1, 2, 3, 4, 5, 6. It's been a minute since I've sketched serrate antenna, so I was excited to show you guys this, but also it's a little bit of practice for me. Getting the shape back into being about right. So I've got this, my serrate antenna kind of taken care of. I believe that some of you, let's see. I'm excited to see some of your sketches also, because I've seen some of your work with, especially all of this texturing, and it's absolutely beautiful. What does IRMO stand for? Oh, it reminds me of. Yeah. So, I guess that's a fair comment. The tarsal segments kind of the antennal segments remind us a little bit of those tarsal segments. And I guess, yeah, they're kind of triangular and they fit into one another. For sure. All right. You ready to see what makes these beetles click? When the lighting readjusts. Alright, so if we are looking at the bottom side of our click beetle, what we're looking at is up here. Up here, this is the bottom side of the pronotum, and then this is underneath the elytra, all right? we do have this. This is what we call the prosternal process. Or at least this is the prosternal process, and it's essentially like it's the process that the click beetle will actually tuck into this little groove, and it's what creates kind of that friction for the ability for it to click, right? I'm sure that at least some of you have picked up a click beetle and flipped it upside down and played with it a little bit. And so that having that little process down there that fits into this little notch will actually is the process, or is the these are the body parts, I guess, the anatomical features that create that ability to do that. So we've got the prosternal process, which is essentially the finger that fits in, and then there's a name for the groove too. The groove on the bottom is what we call the mesosternal fossa. Now, we've all been here for a couple weeks. We've been working together. We've talked about pro, meso, meta with insects, right? Talking about the first segment of the thorax, the second segment of the thorax, and the third segment. So when we're saying meso, we're just saying the second segment of the thorax and the sternum. The sternum is the bottom side. So we've got the mesosternal fossa. And the fossa is a word for kind of like a large gouge or a divot. And that's what we're looking at here. And I'm going to go ahead and I'm going to zoom in real good so we can see that. Doop, 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 doop. There we go. So up here, this is the prosternal process, and down here is the mesosternal fossa. And it essentially is what creates the clicking noise and its ability to flip. All right. And I sometimes think that if you look really closely at just this image, these little circles right here are the coccyx, or the hip sections of my beetle. And I think sometimes they look like eyes and a nose, and then kind of a mouth, or a man with like a beard. I don't know if you guys also see that, if I'm just a little crazy, but I definitely see that when I'm looking at him. Yay! Gonna go and flip this guy over. Now, let's see. I want to go ahead, maybe I'm gonna just start, maybe I'll just start my sketch with the bottom side of the pronotum. So this is kind of where the mouth parts would fit in up here. There's a spider that Pringles is trying to rename into what? So with my sketch right here, funny enough, I'm going to try and match the top, match the outer edges of the top as much as I can. All right. Alright, so this is going to be kind of the bottom side of my pronotum. When you're looking, I think it could be a little more narrow. Maybe that's what I need. That's looking better. right, so when we're looking at this, we can see a couple of different ridges. Right about here, from the bottom side of the mouth parts all the way down to the coccyx, on both sides, we have this line, this thickened part of the exoskeleton, and it actually is defining. Excuse me. Excuse me. All right. It does define the bottom. We call this the prosternum, is right here, this middle part. So this right here in between is the prosternum, and that's why we call this the prosternal process, because it's just another piece that's coming off of the prosternum. But on the other side of this line, this darkening of the exoskeleton, thickening of the exoskeleton, we have this outside flange and this one, and these are the hypomerons. Hypomeron. And that's what these are called on the outside. We do have very circular coccyx on the bottom of our pronotum. And then we have the process coming out from underneath. Its current name is the kidney garden spider. I'm going to have to look it up. Thank you for sharing. And it looks like their logo. Oh, that's funny. Well, I'm glad that spiders are popular enough that a company like Pringles thinks that they should have them as a mascot. I think that that's pretty cool. Maybe we can get rid of the stigma behind spiders. I mean, I think that, that jumping spider, what was the name of the really cute jumping spider that everyone felt? Lucas! I think that Lucas was helping a lot of people out with that, their fear of spiders. Alright, I'm going to go ahead and give my, my pronotum, my prosternal process. Comes down and around. What creates the click? And these circles, those are the coccyx, those are the hip bones that are going to be connecting our femurs and our femur to the body. All right, and then on the other side, we've got the mesosternum. And that's going to be this whole segment that is the second segment of the thorax. So let's go ahead and look at what that looks like. So I would definitely say we've got the second segment of the thorax generally is going to end at the second pair of legs. So that's right about here. So the second segment is very, very thin, but also this is where the elytra are connected. The first pair of wings. This is where the wings are connected. Just go with that. Okay. Alright, so I'm going to go ahead and kind of base my sketch off of where my process ends. So we're going to create this notch here, which is that fossa, that notch that the process goes into. And then I'm just going to go ahead and create this very, almost like, let's say, what shape is this? It's kind of like a square with with these segments, because this is where the second set of coxae are, right about here. And actually, they're less circular than the first set. They are a little more rounded, kind of like this. And that's where the second pair of legs gets connected. And then we'll see a long space between the second and the third pairs of legs. So way down here, this is where the third pair of legs get connected. So this whole section right here is what I would consider the metasternum, the third section of the thorax on the bottom. And in the third pair of legs, on the hind legs, the coxa is not kind of an individual section. So this is the coxa on this guy. It's kind of one defined segment. On the hind legs, we don't have an individual coxa. We have something that scientists like to call a coxal plate. So rather than having an individual, this whole thing, from here, it kind of swirls up to the edge. That is the hind coxal plate. And that's where the leg is connected to. And so if you were talking about the hind legs, like hip bone, it's more of a larger plate on the hind leg. And this is why when you look at a beetle from the top, it looks like sometimes that beetle has legs coming out of its abdomen, because sometimes we don't realize just how long the third segment of the thorax can get. I'm going ahead and kind of sketching these coxal plates that come all the way around to the edge and curl over. And then those are going to have the legs that come off. Now, you all know that we've had that word, the trochanter. That's kind of like that knee-like section. And on the hind leg, it's kind of bulbous. That's going to be what that is right there. And then we've got the final abdominal segments. So I'm going to go ahead and scooch our specimen. This is as far zoomed out as I get. But it looks like we have 1, 2, 3, 4, 5 abdominal segments. 5 tarsal segments and 5 abdominal segments. All right. 1, 2, 3, 4. So the first one you can see is kind of shorter than all of the other segments. It does kind of get cut into by the coxal plate. So you can see that, at least from this angle, you can see way up here that there's kind of this another triangle that goes up a little bit. The coxal plate kind of goes over top of an abdominal segment at some point. And so that's why it's kind of angled like that. How is everyone doing? Are are we doing well with our sketches? Are there places that you really would like to zoom in on? Really examine more thoroughly? I threw a bunch of fun words at you today that were all new that we hadn't talked about previously. Especially in this region where we're talking about specific characteristics that click beetles have that other beetles generally do not. The necklace got all sideways. There we go. I had someone mention a little bit earlier that they were also going to be drawing their own click beetle that they had seen that had the two white spots up at the pronotum, like the eastern-eyed click beetle that I showed a little earlier. So, if you would like, I can just go ahead and really quickly put mine underneath the microscope so you can see the hairs of this click beetle, because I think it's kind of interesting. So this is Alauis oculatus. And it's got this kind of white speckling all over its elytra, but then it also has this white around in the pronotum and these very dark looking eye spots. And from first glance, it just looks like color. But as you zoom in, you'll notice that all of the white areas are just hair. They're like scale-like seedy. So all of, let's see, all of this white spotting here and all of the white spotting, especially along the edges, we'll be able to see this really well. Come on. Image froze. There we go. Cool. Alright, so especially here on the edge, you can see that each of these individual white spots, these are all small tufts of hair. It's not just a color on the exoskeleton. So if you handle these beetles too much, you can take the white right off of their exoskeleton, and these beetles would be just pure black. So all of that is hair. I have a question about the clicking. So, is its main goal to jump/flip with the click noise being a sound effect, or both? I believe that the sound is mostly a sound effect that just happens with the fact that they need. So these beetles, the issue lies in their legs. All right. We saw when we were sketching them that the legs were very, very thin, but they're also kind of short for a beetle of this size, right? If this beetle gets stuck on its back, there is no other way for it to stand up because its legs cannot help it flip over. All right. And that's the main goal of this clicking, of this jumping, flipping, is to be able to put themselves back on their feet. Keep in mind that anything that you see in an animal, whether that is really awesome antenna or interesting tarsal claws or a prosternal process, all of these features on insects are there for a reason. They are there to kind of help with the survival of the species, right? They were chosen via natural selection. So, I would say at some point in these click beetles' lives, they were having a major problem landing on their backs and not being able to flip back over. And it was such a problem that they weren't surviving. So millions of years later, we have little beetles that can flip themselves back over using a flicking motion. I do think there is some mimicry when it comes to click beetles. So if you'd like me to go on a mini story time rant about click beetles, story time. There is, and I'm not going to sketch story time. There is a genus of cockroaches. There's a genus of cockroaches called the glow spot roaches, and these are available in the pet trade, unfortunately. I don't believe you're allowed to have them without permits, but they are pretty much readily available. There are 12 species, I believe. They're all in the same genus, which is Lucy Hormetica. Anyway, so there's a glowing cockroach, all right? It actually glows because it feeds on a fungus. It feeds on a fungus that is bioluminescent, and it creates these two spots on the back of its pronotum that actually bioluminesce because its food source bioluminesces. So in captivity, they don't glow because they don't eat the bioluminescent fungus. They eat carrots, and it turns their spots orange, and it's really cool. But in the wild, especially in South America, where you've got the many species of this species of cockroach, there is also a species of glowing click beetle. And there was actually research done. The spots on the click beetle are at the very, very edges, the lateral of the pronotum. It's right about here that they glow. Well, on the cockroach, they're not all the way on the edges. On the cockroach, the glow spots are a little closer to the center. Scientists realized something, though, because they measured the space in between the glowing spots. So, in between the glowing spots on the click beetle, and in between the glowing spots on the cockroach. And they are the same distance apart. But not only are they the same distance apart, but they both bioluminesce. The click beetle and the cockroach, they bioluminesce at the same light frequency, at the same exact color. All right? And so there in South America, where there used to be pretty much zero light pollution, when the sun went down, it was pitch dark. You had cockroaches that became mimics of click beetles, because these click beetles that glow in South America, they're toxic to birds and other animals that eat them. And so you've got these really nifty little cockroaches that think that they're going to get away with not being eaten because they glow just like the toxic click beetles glow. Well, unfortunately, light pollution is happening. And so as the cities encroach closer and closer into the rainforest, and as the rainforest gets cut down, and as, people start putting up streetlights and those types of things, there's more and more light in the forest, and the predators are able to tell the difference between the click beetles and the cockroaches. So the cockroach populations are in drastic decline because of light pollution. And I think that that's one thing we don't consider with light pollution, is the fact that some animals really require absolute pitch dark just to be able to survive, like our beautiful friends, the glow spot roaches. I believe there's something like 12 species, or maybe 14. There's definitely one species that hasn't been found for like 100 years now, so we're thinking it likely is extinct because it hasn't been collected. There's been a couple of searches where it was last found, but there was a major volcanic eruption at the only place they were ever found. So there are many scientists who believe that that beetle, or that cockroach went extinct during that volcanic eruption. It seems like the click could, you said that it seems like the click could serve as a defense mechanism to scare away predators. I mean, I'm, I, I'm not here to say no. It's definitely possible. I would think that if it was going to be a defense against predators, that the click would be more like that drastic like movement with their body does have the ability to kind of make them slip out of your hands. So if you've ever tried to hold a click beetle that was clicking ferociously, right, clicking back and forth, eventually they kind of wiggle themselves out of your fingers with that clicking, with that clicking movement. So it's possible that that clicking movement is not only for flipping themselves back over and onto their feet, but also getting out of the grip of a predator. I would lean towards that. And that maybe if the beetle clicked in somebody's mouth, it would startle him. I don't know if a click beetle would click before it was attacked, is what I'm thinking. Because normally a click beetle has to be, it has to be either on its back or being interacted with in a negative way for it to click. And so it's kind of like it's a reaction, not an action, I guess. Yeah, so they've clicked and poked when you poked them. And so that's what I'm thinking, is that it's mostly a reactionary behavior. It's not something that they're going to click to scare you away, but they're going to click to defend themselves, to maybe. I mean, Aisha, it's very possible. Awesome. Very good. So it looks like we have our click beetle generally sketched. I didn't sketch the legs on the bottom side or our mouth parts. We could get into that. If you would all like, we have been on for about an hour, a little bit over an hour, so I always like to check in and make sure we're all doing okay. I super appreciate all of you being here with me today and checking out my click beetle. I will make sure to have a Japanese beetle for this Sunday's class, so that's what we're going to be sketching this Sunday. And maybe I will have more of my click beetles identified. Awesome. Alrighty, so I think... Ooh, cat's startling me. I think if we don't have any more final questions about click beetles or behaviors, click beetles as immatures, we call them wire worms, and they look very similar to mealworms, with a handful of differences. They're more solid, they're more like wiry. Hard to describe without seeing them, but we call baby click beetles wire worms. Yay! Alright, so let me go ahead and find this page. Alright, thank you so much, ladies and gentlemen, for hanging out with me today. I always love chatting with you, and I always love sketching with you. I come out with multiple fun sketches every week, and I've got a large growing collection of them. I've actually been trying to decide what I was going to do with all of my sketches now that I have them. I do teach on a platform called OutSchool. This is for students ages 5 to 8, 9 to 12. I do also teach high school level kind of college prep entomology. So you can always go ahead and check that out. If you follow my link in the description box, you will get $20 off of, well, you get $20 from OutSchool to do with whatever you would like. And you can, so you can have a couple of classes with me for free. All right, that is just a reminder to make sure that you subscribe. There's a beautiful little subscribe button. I think it's yellow. It's got a fun little bell next to it. If you click the bell, you get a notification to your phone that lets you know that I am live and doing something fun. We do a lot of these sketches Thursdays and Sundays. Every now and again, I'll go live randomly while I'm pinning bugs, or one of these days, I'm gonna give you a collection tour. So we'll be able to see all of my collection. I think that that'll be a fun time. I'm getting some positive comments back in the chat, so I appreciate you all sticking around and hanging out. This right here is where you can donate to Insectopia. You can donate to me to help me continue to grow and to help me continue to do this as a job. Right now, I have a handful of opportunities that I'm looking at, but this is what I love to do. And so getting a couple of tips in here and there really, really does help me. So consider doing that. And if you're looking for me on Facebook or on Instagram, my tag is going to be at Insectopia 2015. That is the year that's the year we started. And Insectopia was taken, so 2015 is where it's at. And you can find me, I've been posting fun, like, story times on Instagram and, reminders on Facebook and all of the things. So feel free to reach out. I love seeing your sketches. My website is theinsectopia.com, and there's a little contact me section where you can go in and you can send me images if you would like. So if you feel like you would like to scan or take pictures of your sketches and share them with me, I always love seeing them. And I think that is about it. So thank you so much for hanging out with me, for interacting with me, asking me all of the wonderful questions, and I will see you all on Sunday, or not next Thursday, because I'm going to be on a bug collecting trip. But we will be back on the July 21st. Yeah. I'm going on a variety of, I've got a handful of weeks that I'm not going to be in session because I'm going to be going on collecting trips and conferences and that type of thing. I will try to stay active on Instagram and Facebook, though. So if you miss me, come and see me there. All right. Have a wonderful rest of your week and stay buggy.